to today's daily Leetcode challenge. We'll be doing the question and then comparing our solution to solutions of those in the existing database. And let's begin. Question 81. Search in rotated sorted array 2. There is an integer array nums sorted in non-decreasing order, not necessarily with distinct values. Just a little heads up, this question, or a very similar one, this first version of this question, search in rotated sorted array, we did do about 2 days ago. This is the second version of that, and the modification, it seems like, is here. It's saying that it's not necessarily all distinct values. So there is an integer array nums sorted in non-decreasing order, not necessarily with distinct values. Before being passed into your function, nums is rotated at an unknown pivot, index k, such that resulting array is still sorted but around some pivot. For example, 0, 1, 2, 1, 2, 4, 4, 4, 5, 6, 6, 7 might be rotated at pivot index 5, becoming 0, 4, 5, 6, 6, 7, 0, 1, 2, 4, 4. Okay, so makes sense to me right away. Given the array nums, after the rotation an integer target return true if target is nums, or false if it is not nums. Okay, so to start off, if you recollect what we did previously, and I'll link a video to that question now, what we did was a binary search over the input array without ever sorting it initially, but with the condition that we first decide where the pivot is, either in the left portion or the right portion of the array, and that gave us some that enabled us to understand where we can apply certain logic. And I'm going to first actually just implement the first solution, the solution to the first version of this problem. And that went something along like this. We had all the values set up to do a binary search, and while low was less than or equal to high, mid was equal to low plus high divided by 2, and if target equaled nums mid, I would return true, else if target no. And now we have to decide where the pivot is, right? So if the pivot is in the left portion, then we know that the right portion of the array is monotonous, and we can make some assumptions based on that. So this is how it was in the previously. We would say that if nums low is greater than nums mid, we know that the left portion is definitely correct, so monotonous, or just sorted. Sorted would be a way easier way to say this. Let's say that it was sorted, and if it's sorted, then we can make a normal comparison. We can say that if nums low is less than target, which is in itself less than mid, then, well, that means that the target is definitely in the left portion of the array. So we set high to mid -1. Else, if we know that it's definitely not there, and we know that the left portion is sorted, well, the only chance is that it's in the right portion of the array. So we set this. And very similar symmetrical logic goes to the right portion, except that now we're not actually checking if the if the left or the right is sorted. We just assume that the right is now sorted, and if so, we say that if nums mid is less than target, which is in itself less than high, then simply do low is equal to mid plus 1, and else high is equal to mid minus 1. Perfect. So that is our binary search over the not so sorted array. Well, sorted but pivoted among about a pivot, and here we would return false. And so this used to work. Let's see how this does now. I'm pretty sure that there's going to be at least some slight modification we can do, and immediately we get something wrong. So why is this wrong, right? So what really causes this to be wrong? Well, previously we were going on this condition to see if the left or the right portion of the array is sorted. Now we can no longer do that. Actually, we can, and we have to say we have to make some assumption like nums low might be less than or greater than or equal to nums. Let's see. But this doesn't even indicate that the array is sorted, right? This doesn't tell us that the array is sorted. So what can we do? Well, I propose a situation where we identify a portion of the array that is definitely not sorted. So what is an array that's definitely not sorted? Let's remove this for now. An array that's definitely not sorted would be one where low is greater than mid, right? If nums mid is greater than nums high. So what does this show us? A situation where nums low is less than. Sorry, no, I'm doing this wrong. Nums low is greater than mid. If nums low is greater than nums mid, that means that the left portion is definitely not sorted and the pivot has to be in that section. If that is the case, then we know that the right portion is definitely sorted. And if the right portion is sorted, we apply the same logic that we did previously. If nums mid is less than target, which is less than itself high, then we know that it's in the right portion, and we know to say low is equal mid. No, sorry, we know that it's in the right portion, and we know to say low plus 1. Else, this is the condition where this is that we know that the right is sorted, but we know that it's not in the right portion of the array. So we say high is equal to mid minus 1. And symmetrically, we apply the same logic here. If nums, so in this case, we know that the left portion is definitely sorted. So if and if the left portion is sorted, we are able to make this condition. We're able to ask this question. is low bigger than target, bigger than which is less than nums? Is target bigger than low and less than mid? If yes, then we know that it's in the, sorry, one more time. If mid is greater than high, we know that the left portion is sorted, and we're checking here if it exists in the left portion, right? And if it does, then we say high is equal to mid minus 1, else it must be in the low equals mid plus 1. However, there arises another situation where it's neither of the pivots are, we actually, it's not that we know where the pivot is, it's that we for sure don't know where the pivot is, like in this scenario. And in that scenario, I propose doing something like this: self, and we just call ourselves self search with a nums of low, mid plus 1, or self search nums mid plus 1, high plus 1. What this does is if we don't know, oh, and it requires a target. If we don't know for certain that it's in the left portion of that the pivot is in the right portion of the array, or if we don't know for certain that it's in the left portion of the array, well, then we have to do a simple search. We have to search that we have to search both left and right values. Let's see if this works. And I should have used that test case previously. Error recursion depth file. Okay, did I? What? Sorry, I don't know what that was. I hope it didn't delete everything. Okay. It was max depth exceeded. What could I be messing up here? Let me, I think I remember the test case. It was this, and we were looking for 0. Now it's claiming that we've exceeded a maximum recursion depth. So it must mean that somehow, somewhere, I went into a loop. I went into this where I should not have. Let's see what could be happening if target is equal to 9. Okay, I'm thinking, should I be if nums low is greater than nums mid, that means that the pivot is in the right section of the array. If it's in the right section of the array, then I can make a, okay, so pivot in the right, pivot in the left. If a pivot is in the right, then I can say, should I be doing this? Should I be checking if, I think so. Because a target that is less than or equal to nums high would also indicate that it possibly is in the left section of the array. Pivot is in the right. Pivot is in the left. Sorry. Pivot is in the left because low is greater than mid. My bad. If pivot is in the left, then I'm checking what's on the right. I'm checking what's on the right. Target is less than or equal to nums high. So we're searching the right, and we're searching the right. We're saying that low is equal to mid plus high, mid plus 1, which is fine. And if not, then high equals mid minus 1. What doesn't add up here? The next portion, nums mid is greater than nums high. That means that the pivot is in the right section, so we're searching the left. Nums low is less than or equal to target. Nums mid high then is equal to mid minus 1, else low equals mid plus 1. Else return. I am wondering if I messed these up. Target, I think I'm am I exceeding a loop too much because of this? Maybe. But then how will I ever end up on a target that is mid? That means that I have to converge to low always. And is that always going to be the case? Let me add this test case once again. See if that works. Okay, it does. Okay, so I think, nope. I think I'm gonna be getting these situations here where I have to take into account different edge cases, like it's 1 or it's none if I don't include this 0 here. But what is going on? I'm not converging on some value. So I think I might be, but I'm being subtractive. I'm removing 1. I'm removing when I'm did I do something wrong here? Mid. Should I not be including this here? Hold on 1 second. Let's also use this test case. And let's run this one more time. What I'm thinking is I want to, when I search over an array that, there we go. I wasn't supposed to have this mid here. Why is that? Because mid is pointing to 2, and I want to exclude 2. So I'm pretty sure that this should work. I want to exclude 2 from my, okay, submit. Awesome. Okay. So the catch there was when I went into a recursive, wow, that's slow. When I went into the recursive function to find my target in the left portion and the right portion, I was including the center piece, the target, that I have already checked that and made sure that does not equal target. So all I had to do was remove that mid from the subsequent search. And so, okay, so clean solution, but I'm seeing that this is only a 60. And this is where we would go into, or we are going into, a comparison of solutions to other potential solutions. Let's see what's happening on the left side of the on the left side of the solution runtime. And they seem to have the same structure. So it's a binary search where we're doing same thing here. Num's target, we have the same, and even very similar things here. But I'm seeing this, and this is throwing me off. So what are they saying here? If num's left is equal to num's mid and num's right is equal to num's mid, so are they just saying that if they're not sure where the array, where the pivot is? Well, see, for me, I was saying that if pivot is not, or is in the right, but here they're not saying that, they're being more opaque. They're saying that we want to see a solution, or we want to know for sure if this is not making sense to me. How would this tell this person that the pivot is not in the left portion of the array? Okay, I see what they're doing. Let me try to replicate it with our code. They're claiming that no, we don't ever do binary search, or we don't ever do recursive call. What we do instead is, instead of making these assumptions that, or not assumptions, these strict condition assertions that pivot is in the right or pivot is in the left, they're saying this: if nums low equals nums mid, and nums mid equals nums high, then low is equal to low is plus equals 1, high is minus equals 1. That's what they're saying to do, right? Else. Yeah, but why does that work? How am I able to... And that does run around a lot faster. Wow, 98%. That does run a lot faster, but how does that make sense? Does this somehow eliminate the situation where... Well, actually, no. Let's approach this with the same logic that I was proposing. That we have these two situations where we know for certain a pivot is not, or a pivot is in the left section of the array, A pivot is in the left array, means that we can make some assertions. A pivot is in the right. We also make some conditional logic. But what does this do? This says that if a target, if all three values, low, mid, and high, are equal, then, well, yeah, removing them doesn't affect our search, because I mean, I guess I see what's happening. If this doesn't happen, if this condition doesn't meet, then one of these will or should meet, because if at least one of them is the same, num and low and mid, for example, then that still leaves the possibility for mid and right, which is actually checked here, to be different. And in that case, if mid and right is different, that leaves the pivot to be in the left. Okay, this is a bit confusing. To be 100% honest, I like our solution more, but this one runs faster, and I feel like you can build some intuition into this also. But okay, well, I'm gonna show both of these solutions as well. This is the one that beats 98%, and this is a slower solution, but I believe is more intuitive. So there we go. Okay, well, thanks for watching, and I'll see you next time. Bye.